Alright, so we are going to discuss the algebra of functions. Okay, so in particular, when you think of numbers, you do some kind of arithmetic with numbers, like adding, subtracting, multiplying, and dividing. Well, likewise, you could do the same thing with functions. You could add them, subtract them, multiply them, and divide them. And so here we have what's called the algebra of functions, or how the algebra of functions is defined. So suppose if f and g are continuous, suppose f and g are functions, and x is in the domain of each function, then we define the sum function, f plus g of x, to equal f of x plus g of x. Then we could define the difference, very likewise, f minus g of x, as the difference of outputs. In other words, f of x minus g of x. We could define the product of f and g. So f of g of x can be defined as the product of the outputs. In other words, f of x times g of x. The quotient of f over g, in other words, f of g of x, can be defined as the quotient of the outputs. In other words, f of x divided by g of x, provided g of x is not 0. All right, so let's see how we could work some of these examples out here. Let's see how we could use these definitions to evaluate. So given that f of x equals x plus 1 and g of x equals the square root of x plus 3, find each of the following. All right, so we're actually finding f plus g of x. So by definition, this means we're going to add the output of f of x plus the output of g of x. And so what we get is x plus 1 plus g of x, which is plus the square root of x plus 3. And that's it. B, we want to find f plus g of 6, evaluate at 6. So this would be f of 6 plus g of 6. Well, f of 6 is just going to be 6 plus 1, which gives us 7. And g of 6 is 6 plus 3, which is 9, and then take the square root of that, which is 3. And so we get 10. Alternatively, we could use the fact that we have what f plus g of x is by part A. In other words, we have the formula already. Okay, so we could use the formula directly. F plus g of 6 is equal to 6 plus 1 plus the square root of 6 plus 3. So we get 7 plus the square root of 9, which is 7 plus the square root of 9 is 3, so we get 7 plus 3, which is 10. Okay, so whichever way preferable. I mean, if you have the formula, then that's probably the way to go. All right, f plus g of negative 4. In other words, f plus g evaluated at negative 4 is found by plugging negative 4 into f. Well, actually, I'm just going to plug it into the formula here. And so we have negative 4 plus 1 plus negative 4 plus 3. And notice this here is defined, but if you evaluate this here, that's the square root of negative 1, which is not a real number. And so we got to be careful when we plug in inputs into sums and products and differences and quotients, because the inputs might not be in the domain. For instance, this is part C here. Note, negative 4 is not in the domain of G. All right, continuing on with that concept of domain. Well, domains of the sum and difference and product and quotient, you got to be careful, as we saw with part C here, the previous example. But if we're looking for the domains of these functions, then how do you find them? Well, if f and g are functions, then the domain of the functions f plus g, f minus g, and f times g are each the intersection of the domain of f and the domain of G. In other words, we need to figure out what inputs do F and G have in common. In other words, what values fall in the intersection of their domains. And the domain of F over G is also the intersection of the domains of F and G, with the exclusion of any x values for which g of x is 0. Alright, so here we're given f of x equal to the square root of x, and g of x equal to the square root of 2 minus x. A here says find the domain of f, g, f plus g, f times g, and f over g, and g divided by f. We probably also could, input f minus g here as well. But in any case, first to do this, we need to find the domain of f and g. All right, so to do that, well, what is f? F is equal to the square root of x. And we know from that we need the radicand, which is just x, to be greater than or equal to 0. And so that there is telling us the restriction on x. It has to be greater than or equal to 0. Okay, so then that means the domain of f, and I'm going to abbreviate so I don't have to write so much. We use a capital D for domain and a subscript of f to indicate the domain of f. And this equals, well, all real numbers greater than or equal to 0. And I'm going to use interval notation here. So it's going to be bracket 0, open bracket 0 to positive infinity. Closing parenthesis. Now g of x is similar. It's the square root of 2 minus x. And so once again, the radicand here is what's important. We need 2 minus x to be greater than or equal to 0. All right, so then I would add x on both sides. Actually, I like to put it on the left, so let me go ahead and subtract 2 on both sides there to get negative x greater than or equal to negative 2, and divide by negative 1. And when you divide by negative 1, the inequality reverses, so this becomes now less than or equal to a negative 2 divided by negative 1, which is positive 2. All right, so that tells us the domain of G is equal to, open parentheses, from negative infinity to 2, and then a closing bracket. Okay, so all the real numbers that are less than or equal to 2. All right, so to find the domains of the other functions, we need to figure out the intersection, right? We need to figure out the intersection of, or the intersection of domain of f intersect domain of g. So if you don't know that symbol there, that symbol that I'm drawing the arrow to here is what's called the intersection symbol. It's like an upside down U. Okay, well, let's visualize that in terms of a number line. So if you have a number line, the key numbers here we're looking at, we'll say negative 1, say negative positive 0, I'm sorry, 0, positive 1, positive 2, positive 3. And then let's graph each interval here. So let's graph the domain of f, which is from 0 to infinity. So 0 to infinity would be a closed or a filled in circle, right? And shade everything to the right there. That's the domain of f. All right, now if you were to graph the other inequality, or the domain of g, we would have a closed filled in circle at 2, and then shade everything to the left. And that's the domain of g. But where do they overlap? Well, you notice they overlap here and here. In other words, you want everything between 0 and 2. So the domain of the sum, the difference, and the product is going to be where they intersect, where they overlap. And so what do we have here? Well, we have that the domain of f plus g the domain of f minus g, and the domain of f times g, they all equal bracket 0 to 2. I'm sorry, bracket, opening bracket, 0, comma, 2, closing bracket. Likewise for the domain of each of the other ones as well. All right, so that's the domain of those guys. Now, we also were asked to find the domain of f over g and g over f. So what's the domain of f over g? Okay, so to do this one here, you gotta, it's going to be equal to basically what we just wrote for the other ones, 0, comma 2. However, we need to exclude any value that makes the denominator, which in this case would be g of x, to 0. And what is g of x? Well, g of x is 2 minus x equal to 0. So you would have to square both sides to get 2 minus x equal to 0, which says negative x equals negative 2, or x equals 2. So we need to exclude the value of 2. And so, in other words, we would have to eliminate that 2 in the interval from 0 to 2. And so that would mean that we would go from bracket 0 to 2, but instead of a closing bracket, we would have a closing parenthesis to indicate that we're not including 2. Likewise, we're trying to find the domain of g over f. This time, though, we don't want f of x to be 0. And so we need to figure out where those values are that make f of x equal to 0. In other words, in this case, we have square root of x equal to 0, which tells us but square both sides, we would get x equal to 0. So we need to exclude 0 this time from the closed interval from 0 to 2. All right, so then we would have an open parenthesis now for 0, and then a closing bracket for 2. Okay, so it's an open half closed interval there. So this time we are excluding 0 from the interval. All right, so in terms of inequalities, remember this would be x less than or equal to 0, 0 is less than or equal to x, and x is less than 2 for that guy. And this one would be 0 is less than x, and x is less than or equal to 2 positive 2 there. All right, part B here, we're asked to find what f plus g of x is. In other words, and f minus g, f times g, f over g, and g over f. All right, so let's take our functions. We have f of x plus g. So by definition, what does this equal? This is just f of x plus g of x. F of x is the square root of x, and g of x is just the square root of 2 minus x. There's nothing you can do there to simplify. That's what it is. And then let's see, what's f minus g of x? Well, that's just going to be f of x minus g of x. So very similar to what we just got, except it's square root of x minus the square root of 2 minus x. Okay. All right, and then we got f of x. Oops. F times g of x. So this is just f of x times g of x, and then we multiply them. So we have the square root of x minus, or not minus, but times the square root of 2 minus x. We might make that look prettier by writing this the square root of 2x minus x squared. And you can do that because of the properties of radicals. All right, f over g of x. We got this equal to f of x over g of x. And so f of x is the square root of x over g of x, which is the square root of 2 minus x. For me, this is fine. Sometimes, though, we're asked to go further. Sometimes it's a bad thing to have a square root in the denominator for some reason. And so you might see some textbooks or videos might rationalize it where they're multiplying top and bottom here by the denominator of 2 minus x. I don't think we need to do that, but I'm going to just show you for completeness here. And square root of x times the square root of 2 minus x, we can write that as 2x minus x, square root of 2x minus x squared, and the bottom we would be left of 2 minus x times 2 minus x, and so we're left with 2 minus x. technically probably an absolute value there, but I'm not too concerned with that. I think we could just stop right there. Okay, the other one is very similar, g over f. Okay, so g over f of x is g of x over f of x, and then that's just the reverse of what we just had, so that's 2 minus x all over the square root of x. And then if you rationalize it, you would rationalize by multiplying top and bottom by the square root of x. Alright, so what would you get? You would get 2x, the square root of 2x minus x squared all over x. Alright. Next example. We're given two functions, g of x and h of x, by the given graphs below. Okay, and we want to use these graphs to find particular function values. All right, so for a here, we're asked to find g minus h of -3. So by definition, this is g of -3 minus g, or not g, but h of -3. Okay. And so we have to use the graphs here. So remember the input of, so we're going to need first, to find g of -3, we use the graph of g. And so we have an x of -3. So here's the x value, -3. Follow it to the graph there, and then follow it to the right. And what y value is there? Or figure out the order pair there. So the order pair was -3, -1. So the output would be -1. So then we get -1 there, minus what h of -3 is. So once again, very similar. Here's our -3 on the input for the horizontal. Follow it to the graph, and then follow it to the y-axis. And you can see that we have an order pair, or excuse me, the y value -2. Or just remember that this is the order pair -3, -2. So the output is -2. All right, so we get -2 there. Doing the number crunching there gives us -1 plus 2, which gives us 1. All right, so B, we want to find the product of G times H of X, or not X, but evaluated at -5. So this is G of -5 times H of -5. All right, so let's figure out what G of -5 is. So here is -5, right, for the input. Follow it to the graph, and then follow it to the right. So what y value is that? That's a +3, okay? Or the order pair is -5, +3. All right, so we get a 3 out of there. Oops. And then we need to find the value for h of -5. So -5, here's the input of -5. So then follow it to the graph. There's the point that corresponds to it. And then to the right, we see it has a y value of -2. Okay, so we get times -2 there. So we get -6. All right, C. We're asked to find g over h of 0. So we have g of 0 over h of 0. So g of 0, we could see that would give us this pretty much order pair here, which gives us a y value of +4, excuse me. And h of 0 would give us a y value of 5. All right, so what do we have? We have 4 over 5. Okay, so D, we have G plus H of 2. Okay, so it would be G of 2 plus H of 2. And then once again, let's go use the graph to help us figure that out. So here is G of 2. Or here's the input of 2, follow it to the graph, we see we get an output of 3. All right, same thing for h here. Well, here's the input of 3, follow it to the graph, and then figure out the output, which would be -3. Oops, I think I used the wrong input. Let's see. The input, it's an input of 2, sorry, the input 2, so that means the output is 0 there. Okay, and then 2 here, and output is 3. Okay, so we get 3 plus 0, which gives us 3. All right, next part of the question here asks us to determine the domain of g, h, g minus h, g plus h, and g of h times h, and g over h. Okay, so once again, looking at g here first, we could see that we have an arrow here which indicates that this is continuing on forever there, and we see that means all the x values that are going to be obtained are going to be from -infinity all the way up to 5, but we have an open circle there, so we don't actually get -5. And so so E here, the domain of G is equal to -infinity to 5. All right, the domain of F, or not domain of F, but H is equal to, well, we can see it stops at -5, right? The point, if you follow the graph from left to right, the first x value is -5, and it continues all the way to 6, and it stops at 6 there. So we're going to get bracket -5, comma, bracket 6. All right, now we need to figure out the intersection of the domain of G and the domain of H. Okay, so we know that's going to occur. Well, once again, we see, if you look at examine where they overlap, you're going to see that they overlap from -infinity to 5 parentheses. Okay, once again, where they would overlap. Okay, we'll do a number line if that helps. All right, so the domain of G plus H is going to also equal the domain of G minus H, also going to equal the domain of F, or not F, but G times H. And so that's just going to be -infinity to 5. Okay, once again, because it's where they overlap. All right, but the domain of G over H, it's going to be -infinity to 5. However, we got to be careful and figure out where H of X is 0, because we want to exclude those numbers that make the denominator 0. All right, so using the graph, we need to figure out the zeros of H of X, or where the X values that make that equation true. Okay, so we can see that that's going to happen at this point here, and this point here, because the coordinates for each one of those will have a 0 for the output. And so it happens at X equal to -2, +2, and +4. Once again, -2, +2, and 4. So we need to exclude that from the domain. All right, I'm gonna transfer this down here just a tad here, so I could write this interval. It's gonna be it's gonna be a long interval here. So we would have -infinity to -2 union -2 to 2 union 2 to 4, and then union 4 to 5. We stop at 5 because, remember, we're basically breaking up the interval of -infinity to 5. Okay, and we're excluding the values -2, 2, and 4 from this interval. All right, that's it for this video.